I do want to get through this. So this section is 5.4. It's a rather quick section because it's a continuation of factoring. I can't emphasize enough. We are going to factor more and more and more all year. If you're still having trouble with factoring, please come by on Wednesday or at some point. Let's do a few examples together to maybe reinforce it further. But your factoring skills got to be there. Okay, you got to have factoring skills. So rational algebraic expressions. All we do is simplify. So first, let me ask you this question. Why is that a mistake? Take a look at the common mistake. X over x plus 2. Why can't I just cancel the x's? Why not?
Because x plus 2 is its own number, its own group. If it was like, if x was 1, you can't cancel it because 1 would be 3. So.
Yeah, that's a great example. Let x equal 1, everybody. I get this, don't I? Isn't that what it becomes if you let x equal 1? And what does that equal? What's 1 over 1 plus 2? 1/3. So if I were to do this and cancel and leave a 1 behind, what do I get? I'd get 1/2, wouldn't I? 1 over 2? Which is not the same as 1/3, clearly. So the reasoning for this is because the x in the denominator is not a factor. That's the reason. What is it called? Anyone know the word for that? You can use several words, actually. I don't know. What would the word be to describe the x in the denominator? Like the numerator, that x is a factor. It's really x times 1. The numerator is written as x, but I see the numerator as x times 1. So x is a factor and 1 is a factor because they're multiplying. Things that multiply together are factors. The bottom says x plus 2. So what would you call x? Anyone know that word? A term. Good. You use a term. The other word I was thinking was addend. An addend is one of two things that you add together. Addend, A-D-D-E-N-D. So if I look at this, the numerator is really x times 1. The denominator is really x plus 2 times 1. So as Tristan mentioned a moment ago, the quantity x plus 2 is a factor. Does that factor repeat itself in the numerator? No. If you had x plus 2 in the top and bottom, what could you do? If you have x plus 2 in the top and bottom as a factor, what happens to those factors? They cancel. But what happens here, x plus 2 is not the same as x. But aren't the ones the same? What can I do with those ones then? So what does it just become? It becomes back to what we had a moment ago. If I cancel this one and cancel this one, I'm left with x over x plus 2. So when there are factors, they can be canceled. But if I look at this, I can see that x here and here cannot be canceled for that reason. So what's your goal? You got to factor first, and then you could reduce. Got to factor first, then you can reduce. So this is an example with electric fields. The electric field intensity has to do with the positive charge that will be experienced by what's called the point charge. Simply put, you get this equation, E equals F over Q, where F is some sort of electric force, and Q is a charged particle. E is the electric field. Does any of this even matter? No. I'm just giving you background to a problem. But what happens in the end is that you're told the F function is given here, the value of Q is given here, and you're asked to determine the electric field intensity. That's this right here. So your goal is to figure out the electric field intensity. And the electric field intensity is told to you that it equals the force function, the electric force, over the charge itself. The force function is 2t plus 4. The charge is 8. All you're asked to do is simplify here. Now, I purposely choose this as the first problem we do because most students in this problem make a mistake. The mistake I see a lot of is that they reduce to 8 with one of the numerator pieces and not both. There are two terms in the numerator. So if you're going to reduce by a factor of 2 here, everything has to be reduced by a factor of 2, every single term. So either you could start by doing this, reduce everything by 2, right, a factor of 2, and that's your answer, t plus 2 over 4, like that. Or you could try to take out a GCF out of the top and bottom. If I were to look at this again separately, I could factor a 2 out of the top, which leaves me with that. I could factor a 2 out of the bottom, which leaves me with that. For those that are confused, look at the top. What comes out of both of you? 2 comes out of front. What will come out of 8? 2. So when I take a 2 out front, they cancel. What am I left with? 2 plus t, or t plus 2 over 4. T plus 2 over 4. So either you need to reduce, maybe jot this down, reduce all terms by the same factor. That's what we did the first case. Reduce everything by 2. Reduce all terms by the same factor. Or factor out the same factor, which is shown here and here. And then reduce those two by canceling them out. Either way, you get the same answer. Now, if this was on an SAT, maybe you wouldn't see the answer written like this. Maybe you would see it like this. Why are those the same things? Why might the answer on the SAT be written like this? What is that making you do? Coach? What do you mean?
Like you just simply like they're trying to list you if you can see that you're supposed to multiply or
Okay, we should make this back to t plus 2 over 4, right? But I'm saying, where did this come from in the first place? Look at this line and go there. Go from the previous line to the current line.
you could do you just saying that you have to know to do each factor divided by the common factor.
Each term. Yeah. So what George is saying is this. Well, you know what? Look at this as t over 4, right? And that's this right here. And then when I divide the next term, remember everything has to be reduced by the same thing. That's 2 over 4, which gives me 1/2. So whenever you have a monomial, let's jot this down. Whenever you have a monomial in the denominator, the monomial divides into each term of the numerator. A monomial denominator, monomial, one term, denominator, divides into each term of the numerator. Or must be divided into. So we start a problem like this and we say to ourselves, oh man, I don't know what to take out of here. It doesn't really look like I know what to do. So I take a look at the last problem and I think to myself, well, I factored that one to start. We reduced by 2, but theoretically we factored. So go ahead and factor this. You know, I don't know what to factor out of the numerator, so leave it alone. But the denominator, it's pretty obvious what I'm going to factor. So tell me what I should take out of the denominator. Remember, always start with a GCF. 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 Come on, it should be a chant. GCF. GCF. Tristan.
Well, you can take out 2x from both of them.
So let's start with the denominator, taking out 2x. What do I get? What's left behind?
2x.
What's left behind?
2x.
In the parentheses, what's left behind?
2x, right?
No, if I take a 2x out of 6x squared and a 2x out of 20x?
Oh, on the denominator. So
yeah, denominator, sorry.
Then you get 3x minus 10. Sorry.
That's good. So if that's not clear, make sure we understand. When you take a 2x out of each divided by both. And then what Tristan noticed already was he was like, you know what? If I'm taking 2x out of the bottom, I should probably also take it out of the top, right? And that was smart. So he said, you know what? If I take a 2x out, what's left over here? 2x. Because what's 2x times 2x give you? 4x squared. As a result, we cancel out the GCFs, and here's our final answer. Why can't I reduce those x's? Look, there's an x here, there's an x here. Why can't I reduce them?
Because both terms go into the denominator.
Yeah, the bottom has 2 terms in it. They're not factors. They're terms. Okay, 2x over the quantity 3x minus 10. Try the next one, please. Try to get through it quickly. See how you can do. These are not hard. It's all about factoring. If you can factor, you can easily do these. Nice and quick. Let's go. Nice and quick. Your factoring skills need to be through the roof. So h over g. if I were saving time on a test, I wouldn't even rewrite it. I would just go right to the factored form of both. What do I get? Numerator. Ash, numerator.
X plus 3.
Uh-huh. Whatever, get 3 and
4.
4. I just happened to write it first the other way. And the denominator. Annette?
X plus 3 and x minus 1.
As a result, what happens? Luke?
The x plus 3 is canceled.
Yeah, those 3's cancel. Those x plus 3's cancel. Why can I cancel the entire thing? Because it's a factor. Remember, please look up real quick. This x right here, this little x, that's a term within the factor x plus 3. But x plus 3 itself is a factor. How do I know that? Because there's a multiplication symbol right here that separates two factors. Another multiplication here that separates two factors. Well, if the numerator and denominator contain the same factor, it can be reduced. Can I go any further? It is very tempting to say my answer is just -4. And I can't tell you how many people do that. Because they cancel out the x's and say, oh, there's an x here and an x here. You get 4 over -1. The answer is just -4. But remember, x is a term, not a factor now. X is a term, not a factor. Can't cancel terms, only cancel factors. Had it been x this, had it been this, well, because there's a multiplication symbol, those x's would be factors, and those x's would then reduce. But it's not the case that we have. We have plus instead. Simplify the following rational expression. Why is this one a little bit trickier than the last one? Why is it a little bit trickier?
Because you have to foil.
No. Believe it or not, you don't have to foil, George. Be careful. It's tempting to foil, but you're not going to foil. You're not going to distribute. What does that -1 mean? What is a negative exponent?
It means everything's going to, everything is that, everything's going to go
Into the bottom. So really, here's what I've got. Okay, for those of you that forgot that, a negative exponent means 1 over the positive. So I can write it like that instead. And that's how I do have to write this. Okay, that's how I do have to write this. And now, I can remember that 4x minus 36 is really over 1. So let's go ahead and factor. Please GCF this, please. It makes life so much easier. Don't use AC method. Check my work, please. See if you're the same. So far, I just gave the first step. That's just 4, not 4x. Whoops. So far, so good? Factor applicable? Go ahead and check your work again, please. Now, remember from your basic, obvious, easy, simple fraction math skills from when you're a kid, when you multiply fractions, you multiply the tops and multiply the bottoms, right? So pretty much the top is simply this times 1, which is itself. The bottom of this fraction is this times 1, which is itself. So really, at this point, we can just cancel the top and bottom accordingly. What's in the top and bottom both? Tristan, what's in both spots?
That would be x minus 3.
Yeah, that's obvious. That's the one that's easy. What's the one that's a little tougher to then reduce?
The 4.
Yeah, the 4 and the 2. So you could simplify that. Again, this becomes a 2. This becomes a 1. Okay, 4 divided by 2 is really 2 over 1. So reduce, you get 2 times the quantity x plus 3. All over the quantity x plus 2. Which is tempting again to cancel the x's. But again, x plus 3 itself is a factor. X is not a factor. x plus 3, that whole thing is a factor. X is not a factor. While I have you start the last one, I'll call you up for your quarter grades. We have like 3 minutes left. Tonight, the homework is regular homework on 5-4. I will talk about the quarter 3 project later this week, so don't worry about it yet. Okay? So start the last problem, please. I'll skip to it in a minute just because people are copying this down still. Start the last problem. The last one is annoying because the factoring is tough, but you can do it for sure. Factor the numerator first, and that'll help you factor the denominator. It's going to be AC method you're going to probably need to use.
In the homework, do we do this for tomorrow?
Yeah. Regular homework, regular due tomorrow, the normal situation. Come up alphabetically. Luke, then George. I'll give you your quarter grade. You have your midterm grade already. This is not your semester grade. Okay, semester grade is quarter 1 times 40%, quarter 2 times 40%, midterm times 20%. That answer times 1.04. It's a little bit messy. I thought we had more time. Quarter 2. George?
Okay, it looks like it now, but I actually.
You want to see right now for the
The biggest upset. I stuck.
Anybody else? Come on up.
Wait, I was the biggest upset. I can think.
If you want to see a breakdown, you can see a breakdown at a point in time for sure. Quarter 2. Quarter 2. Quarter 2. I know. It's about time, you know. Quarter 2.
Wait, Bridge.
Quarter 2. Very good. Very good. Yep.
I watched the video for the chapter early this week, and
Oh, what?
it really helped. I watched the video for the chapter that you yesterday.
Oh, yeah? Good. So, you mean for watching it ahead of time before the lesson? Definitely do that. You can do that all the time instead. And you'll have your notes done, so while you're in class, honestly, listen, but you can just do the homework too. If you watch the video at home, you want to practice problems while we're talking, and that works too. Good. Keep it up. Nice, Tristan.
Please tell me they